Now in this recording we're going to look at something called logarithmic differentiation. What logarithmic differentiation does is it allows us to take very complicated functions like what you see here and find its derivative in a simpler way. If you'll remember back when you learned all the properties for logarithms, the sum rule, or I'm sorry, the product rule, the quotient rule, the power rule, you learned that you could take complicated functions like this if they were inside of a logarithm and simplify them into sums and differences. And those will be easier to take derivatives of. Now what we're going to do here is we're going to take the natural log of each side. The natural log of y is equal to the natural log of x squared plus 1 times x plus 3 to the 1/2 divided by x minus 1. Now, I'm going to simplify the right-hand side using those product, quotient, and power rules. Now, what the product and quotient rules tell us is if we have a product, that's the sum of the individual logs. If we have a quotient, that's the difference of the individual logs. So we can break this fraction up as the natural log of x squared plus 1 plus the natural log of x plus 3 to the 1/2, since those are a product, minus the natural log of x minus 1, since that is a quotient we can subtract. Now one other rule we can apply here is the power rule, and that will give us the natural log of x squared plus 1 plus. And with the power rule we can bring the 1/2 out as a coefficient, 1/2 natural log of x plus 3. Now this may not look a whole lot simpler, but now we're going to use implicit differentiation as we did in a previous section. So with implicit differentiation, remember what we did is we took the derivative of each term, left and right, with respect to x. So if I take the derivative of the natural log of y with respect to x, the derivative of the natural log of y is 1 over y, but since I'm taking this with respect to x, I'll have to multiply by y prime, or dy dx. It doesn't matter which notation you use. When I take the derivative of the natural log of x squared plus 1, that will be 1 divided by x squared plus 1 times the derivative of, with respect to x, of x squared plus 1, plus I'll have 1/2 times the derivative of natural log of x plus 3 is 1 divided by x plus 3 times the derivative of x plus 3 minus 1 divided by x minus 1 times the derivative of x minus 1. So I'm going to leave the left-hand side the way it is, 1 over y times y prime. On the right, I have 1 divided by x squared plus 1 times the derivative of x squared plus 1. The derivative of x squared is 2x, and the derivative of 1 is 0, so that's just 2x, plus 1/2 times 1 over x plus 3 times the derivative of x is 1 and the derivative of 3 is 0, so that's just times 1, minus 1 over x minus 1 times the derivative of x is 1 and the derivative of negative 1 is 0, so times 1. This gives us 1 over y prime equals 2x over x squared plus 1 plus, I'm going to go ahead and multiply the bottoms out here, the denominators. 2 times x is 2x and 2 times 3 is 6, minus 1 over x minus 1. Now in order to solve for y prime, that's what we want to know. What is dy dx, or what is y prime? We would need to get rid of the 1 over y. And we did that by multiplying both sides by y. So if I multiply each side here by y, if I multiply the entire side by y, then that will give us y prime equals y. And now remember, y was actually x squared plus 1 times x plus 3 to the 1/2 divided by x minus 1, and we're going to multiply that times 2x divided by x squared plus 1, 2x plus 6, minus 1 divided by x minus 1. Now while this derivative